Okay, it's the next day, officially day 4, I guess, of working on this thing. In the morning, I had the soundboard pulled out, and I was gonna reflow solder on all the connectors, and I started to look to see what caps I had to replace these, the caps on it. But I'm actually going to hold off for right now. I was, never worked on these before, so I had to do, research, read the manual, become familiar with what's going on here. So this is the actually where the power comes in, and we have negative 12 volts and plus 12 volts ground and 5 volts test point. So the first thing I think we should do is put it back in and test for voltage. It does have a 6808 CPU, and it has a PIA chip, which actually I just put my Neolock Inquisitor together, and I have the PIA test board, and I know I have a couple working ones of these from pulled boards because I just tested them I think yesterday. I obviously didn't video that because it was not related to this Joust, but I'm excited because now I can actually test these things, which is good. And it also has some fuses. Now, the one thing I'll mention is that these fuses here are 1 amp that are in here. I pulled them, and they are good. The manual says it should be 4 amps. So I don't know if the manual's wrong and they made a change or what. These, they look like they've never been replaced, and they are 1 amp fuses when I pulled them. So at this point, the other thing I checked is I did verify like all the jumper settings are correct. And if you see here, another interesting fact is this says Williams Sound ROM 2, but then it almost looks like the factory kind of wrote over the 2 with a 4, or because this sticker has definitely never been removed. So no one could reprogram it unless they remove that sticker and erase the EEPROM. So that must be a factory thing. It says they just wrote 4 on top of that sticker, which is kind of strange. And I didn't figure out what these switches are for. These dip switches are here for. I want to find that out. Just I'm curious what those are for, but they're in the on position. So sorry about that. But anyway, we should be able to put this board in, test the power, and if I press this button here, I should be able to get sounds. And I might actually hook up a speaker directly to this to bypass the pot. I think. Wouldn't that bypass the pot? I think so. Or I'll definitely try to see if I can get sound without going through, eliminate the speaker and the volume pot. So alright, that's what I'm going to do. I'm going to put this board back in and test power. Be right back. Alright, so I have my voltmeter in here. Kind of weird that it's actually reading a little bit of voltage there, but maybe from the caps. But I have it hooked up on the 12 volt test point and the ground test point there. One thing that I noticed when I was putting this back in is I actually have one of these. This is a insulation displacement connector, IDC. One of these wires is actually completely out, and it should have. So that could be part of the issue, or it might be the whole issue. I'm not sure. I think each one of these wires controls a different sound. I haven't got that deep into the schematic yet. So I'll have to figure that out, but that definitely needs to be fixed. And just checking my work. Let's go ahead and power it up. Alright, so we're getting 10 volts, which is probably not good enough. $10 volts on the 10 volt line, but minus 12 on the minus 12. I don't know if that makes complete sense. Yeah. See what is our 5 volt. and we're getting a 4.9, which should be fine for the 5 volt. So this positive 12 volt right there does not look good enough to me. So the other thing is, if I press this, whoop, that's new. That's good. The only way to get rid of that noise is to turn the game back off. But I had pressed that before and I didn't get anything. So we're actually getting some sound now, which is positive. I just pulled the board, put it back in, haven't done anything to it, reflowed solder or anything. And we do have some low voltage on the plus 12 side. So I think I'm going to go ahead and pull the board again. Or actually, let me pause and let's run through the sound test and just see what we get on the sound test. Adjustment failure. We'll hit advance. Hit advance again. This is the CMOS error right here that's going to come up. Now we have sounds. It's a little loud. Let me adjust the volume. All right, well that's new. Just from taking the board out and putting it back in. Kind of crazy. I can't focus now. Weird. All right, so maybe flat. Advance maybe. All right, let's do that again. Let's test. We got to figure out how to test more of our sounds. So let me yeah, see those 777s there to me sounds like the CMOS is corrupted, and then it goes into the subtract mode and whatever. So that test diagnostics mode is not working correctly, so I need to reset it. I'll just show you. You just press this reset button right here on the MPU board. Comes up with initial RAM test, all systems go, and then we have our adjustment failure. Well, it looks like all the sounds, I had to put it in auto mode, but I don't know how to advance it manually, but it didn't seem like it wanted to advance manually when I was using the controls right there. But it doesn't sound like all the sounds are working, so I don't know what that loose wire goes to. If it's not needed for this game or something, I don't know. So the sounds are working, but our voltage is still low. So I'm still going to pull the board and reflow solder and see if we can get that voltage better. Okay, I have the soundboard back out again now, and I think I might just replace these headers, the power headers at least, and maybe repin that connector. I'm not sure, just to make it better. The other thing is, I was thinking about why it started working is there's potentially some corrosion or something, on these fuses, and me pulling the fuses and to verify what the amp reading was and putting them back in could have made better contact than it was before. So I'm definitely going to pull these fuses again try to verify whether these are the correct fuses or not. I mean, it's only 1 amp, and it should be 4. But I'll also kind of just, you know, try to clean these up a little bit with some sandpaper or deoxit or something like that as well. And then test the. I don't really necessarily want to pull the caps, but I might put them on my ESR meter real quick just to check them. I mean, the board's working. It didn't sound terrible, but and I think that's it. And then we're gonna go put it back in and see if our voltage is better. So the only thing we really want to do here is get our voltage to our plus 12 voltage to read better than what it is. And maybe the 5 volts might actually get a little bit better as well. So by replacing these headers, I'm also going to reflow solder on all the connectors as well. So that's what we're going to do, and we'll put it back in the game and see where we're at. Okay, so at the bench, I'm going to go ahead and take out these fuses real quick, and just some light sandpaper just to make sure that, you know, there's good contact there. Clean it up just a little bit. Yeah, both of these are excuse me, 1 amp, which 250 volts. So I don't know if the manual is wrong, or if these were replaced. I mean, I would imagine these would be replaced unless they blew for some reason. And the board doesn't have any, you know, noticeable chip damage or heat damage or anything like that. I actually looked at it, the underside too. You'd have to really zoom in, but I don't see any solder reflows at all. I mean, this board looks like completely original from a solder standpoint. Let's see if I zoom in on the header pins. Definitely looks like there could be a few cold solder joints. It wouldn't hurt to, you know, definitely reflow all of these as best practice. Yeah, there definitely looks like there could be a few, but not the power section. Well, the ground maybe, or is that the 5 volts? So yeah, I mean, it's definitely worth doing that. But I'm just gonna, like, you know, clean this up. And then I'll just I'm going to first put some new solder on these, and then I'm going to suck it up. So I'm just reflowing some solder, and then I'm going to use my soldering iron to pull these pins on this power connector. And I'll spare you from watching all this, but anyway, I'm going to do that for basically all the pins. I'm going to use my desoldering iron and basically get these out, and then reflow solder and stuff for all these pins. So I'll be right back after I replace these headers and then clean this up, and then I'll get the ESR meter and we'll hook up onto a few of these caps and just see what they look like. Be right back. Right, I figured I'd show it a little bit more. So I just put some flux, pulled all the pins out of the connector for the most part, and got the connector out, and then I just put some flux on here. I'm going to clean up these pads. and then wipe it off with some Kimtech wipes, a little bit of alcohol. Make sure you got it, get the flux off of there and some of the dirt, and it looks a lot, cleaner. And the alcohol dries, obviously, or evaporates fast. So, and then I'm going to come in with my desoldering iron, and I might need to flow some solder on it. Let me do that. A little bit of solder, just to have enough to clear out the holes. And I might only replace the header on the power section. I mean, that's where you're getting most of the heat and stuff. Okay, got it. Let's see if you can see that. All nice and looks nice and clean. So let me get some new headers, and I believe the key was right there. Pin number 4, I think. And I'll be right back. Get a header to put in there. All right, so. See here, just like that. Headers went in pretty easily. And the thing is, I plan on keeping this game, and so yes, it was working, and if I was just fixing it to, or a lot of people actually, that just might fix it just to sell it or something, wouldn't go through all this effort. Probably they get it working, and then hey, it works, get rid of it. But if it makes sense to do, and you're planning on keeping it for a while. It's almost like buying a car now, Like when you go to pick up these games, especially if you pick them up from a collector, it's good to know exactly what they've done and what they haven't done. Just going there and say, oh yeah, it's working. Well, it could be working for 5 minutes. And then you get it home and it starts acting all flaky and you have to end up doing all this stuff anyway. So either just assume you're going to have to work on it, or ask a ton of questions. And go over it with a fine-tooth comb, which I don't do. I just assume that I'm going to have to work on it and make it easy on the seller. Hey, you know what? It's not going to be perfect. I know that. I'll deal with it. I'm just reflowing some solder on some of these connectors. This is a big pad, so you got to put quite a bit of heat there, just so I can. I like this. All right, so the memory card stopped, but whatever. I ran out of memory card space. But anyway, I was just saying that I like to reflow solder first, and then come back and suck it out with the desoldering iron, and then put all new solder in there. I just, this makes it easier to get it out anyway. I'm not going to replace these headers. They don't look, little, they're not super tarnished or anything like that. There's not a lot of, I don't think there's any power going to those at all, so I'm going to keep working and I'll be right back. Alright, I got the header in, and the key was pin number 7. I'm not really, the only other thing is I grabbed a little Scotch-Brite pad and just sprayed a little bit of electronic cleaner on these fuses and stuff and kind of cleaned them up. I think they're pretty clean, if you can see that. Let's see. Just trying to clean them up and, make sure that there's good contact and everything. And we can put our tester on ohms too, just to see how many ohms, if there's much resistance there at all. Actually, I could have done that beforehand, but just, just get a little cleaner on the, and then just kind of, make sure the fuses have good contact. And still wondering about the amperage on these. Do I have my multimeter here? No, I'll have to do that in a second. And then let's go ahead and put on our ESR meter and test a couple of these caps here. A lot of these aren't high voltage, so that's 0.02. It's a 4700 16 volt cap, which should be like around 0.05. There's no reason to replace that. 0.9, that one, or 0.8 now. That's 1,000 microfarad, and 0.08. Yeah, that one's decent. I don't even know what size this one is. It's good if it's less than 330, it says as a reference. Let me see my cheat sheet here. Probably around 0.2 or 0.5, yeah. So let me see what cap that is. Doesn't really, I can't really see it on here. It's 100 microfarad. 100 microfarad cap. So that one would be fine as well. This is a 470 cap. .17. It's kind of, close. If we, it's not great, but it's not terrible either. I could just replace that one. It was like 0.9. And it's 1,000 microfarad cap. So, you know what? This big one, the 4700, tested real good. I'm gonna leave that one in there, and I'll replace the other ones. 1,000 and the 470. Yeah, 2 1000s, a 470, and 100. I'll go ahead and replace those. I don't have a ton of these 4700 caps, and I don't think this one is reading very low ESR, and I could use this probably on a Atari power supply. So I'm going to do that and be right back. Okay, I replaced all the caps, even these other ones. I think like C26 or whatever. These are 1 microfarad. If you can see that, 1 microfarad, 63 volts. I put in 1 microfarad, 100 volts. So I replaced those 3. So every electrolytic capacitor has been replaced except for this 4700 16 volt one. And the ESR was real low, and I didn't want it, it's a little bit more expensive cap. So normally I probably wouldn't have replaced any of those caps, honestly. But I'm trying to get out of keeping a ton of caps on hand and just like use kits and stuff. So I have a whole bunch of the smaller values that are normally on PCBs. So anyway, yeah, I have them and I might as well use them. This one I only have one, and I think it's on an Atari, or I think it's on an Atari power supply, and I probably could use it, so in a better location. So all right, the only other thing I thought was interesting was this heatsink right here. For that, it looks like the audio amplifier is not soldered in, so it's like, I don't know if it should be. It's definitely making contact with these, so I might see if I can flow some solder on there just to make it a little sturdier. I guess it doesn't matter really, but I'm curious why they didn't solder that there, unless there's paint on that, which on that heat sink, which would cause it to not stick, the solder to stick to it or something. I'm not sure. But other than that, the other thing I was interested in is what these dip switches do. I was reading some threads, and I haven't figured it out yet. But right now mine are on, and I think they're supposed to be off. So that's something else we have to investigate. And I might just clean these pins up a little bit with the electrical contact cleaner and my Scotch pad just real quick. And I think we're done with the soundboard. So I will do those minor things and then put it back in the game and be right back. Alright, I have the board back in. I got distracted at the end of yesterday watching football, so this is actually the next day. But I was looking at it. I wanted to put the board back in. We haven't repinned the power connector coming from the power supply here to the soundboard. It should be getting 12 volt unregulated from the power supply, which I believe is, if I'm not mistaken, is test point 5 and 6 down here. I'm pretty sure. Actually, I could test that out probably pretty quickly here. But then that goes to up here. It gets unregulated 12 volt, and then I guess it gets regulated here by this on the board itself, and filtered by this 4700 capacitor here, which we tested and we know that's good. And I think that's it. So I haven't pinned that out yet, but we did put new headers on. And let's power it up and see what our measurement is. Okay. Well, I'm in AC now. So we're only getting 10 volts. And I know, and it's working. I could go to the front. The sound is working. If you press this right here, I don't know if I covered this already, but if you press this sound test function, it'll start making noises, and it won't go off until you power the game off. So that's a way of testing, I guess, the soundboard without maybe a working CPU board. So let's power off. And we're getting, again, 10 volts there. We'll move our test connection to the negative 12 volt, and we get negative 12.5. And I guess one thing you can do is kind of test it at the filter. I mean at the fuse. So that fuse is getting. The first fuse towards the back of the cabinet, is getting 10.9 volts and 13 volts at the fuse, and then only about on the negative fuse, and only 12.5 there. So I think we should repin that connector But also, let's go ahead and test our power supply as well again. So I'm going to take my negative on my power supply and go to my ground test point. I think it's test point 2 right there. Yeah, it's kind of low. If that is the positive of unregulated 12 volt, that's 11 volts. And we're at negative 13. So it's low on our power supply to begin with, the 12 volt unregulated. So why is that? That's got to be coming straight from the transformer. Obviously it's working, but I would think that we want it to be like around 13 since it's unregulated, especially at the power supply. So I don't remember if we measured that. I'm gonna have to do some research and check into that, because I'm pretty sure that's coming straight from the transformer. And maybe we'll measure it straight from the transformer here in a second. Be right back. Kind of going down a weird road here, but hopefully you guys can see this. I'm gonna go ahead and probably test it like this. See if I can do it without getting my head in the picture. But we're going to test the AC voltage coming in. And the voltage basically goes AC from here on this side of the connector from the transformer through fuse F5 and I think F4, which should be 7 amp fuses. And it comes into this BR1 bridge rectifier, and that basically from that bridge rectifier, that BR1, we get our unregulated 12 volts. So there's basically 2 diodes that I guess create, or maybe all 4 of them. I'm not exactly sure how it works, but it creates the negative voltage and the positive voltage. So let's try to think if I want to unplug anything. In case I bump something, I think I should be alright. I don't like that being there. Like that. Yeah, let's go ahead and power it on. Disconnect my monitor real quick. I'll go ahead and disconnect. Now I'll leave the PCB connected, I guess. All right, let's go. So we're going to check for AC voltage here first. With 1 pin there. .21 volts. 10 volts AC, that's not good. Wow. Both of those should be 21 volts. If I go and zoom on the, change this, zoom in on this transformer. It's on this side. Let's see. Should be gray-green. Is the center tap in gray and black. Is that on the bottom? I'll be right back. Okay, I was looking at the schematic, or it was messing me up because it mentions 20 volts and stuff. Green over here, I think, is the ground or center tap, and so you have no voltage there, and you should have 10 volts coming from the transformer, or 11 point something really. So it's a little bit low, not by much, I mean by a few volts, or I mean by a few tenths of a volt or something. You can also just measure it right here on these fuses. So from the transformer, that 11 volt line comes into this bridge rectifier, which creates the unregulated 12 volts. And it will come, in one direction, come in the negative side, to create the negative voltage, and the positive side to create the positive voltage. And if we go, well, that's AC, and that's what rectifies it to DC power. So now what I did is I unplugged all the gain boards and everything, and if I come to this test point was at 6, I think so, test point 6, we have negative 13.91 volts and we have positive 13 volts, and we were only getting 10 volts there before. So I'm thinking we have some, something is putting a weird load on the system or something. One of the boards could be, something down here. I unplugged the the transistors down here. So let me go ahead and power it off. I'll plug the transistors in on the heat sink, and then we'll come back. Okay, so we have our transistors plugged in there. Getting the same voltage, so let's go ahead and power off. Well, actually, let me take a measurement of our 5 volts here. It's 12, negative 5, 5 volts right here, 5.2. All right, 5.1. That's safe, because I know this. I had moved this a little bit. So, and our 12 volts is at 12 volts, and our negative 5 is right here, negative 4.8. So, you can also test on these sides of the resistors here, going to the LEDs. All right, be right back. Plug in the PCB, I guess. Okay, I have the, can you see? Yeah. I have the PCB plugged in now. I don't have the coin lockouts or coin door lights on. And now my 12 volt test point's only reading 11 volts. And up here it's, down to 10. So either there's a ton of load on there, or, why is that happening? I'm not sure. I guess I could try unplugging different parts of the PCB set. To see if it's the CPU board, the MPU, the ROM, or the soundboard. We can try unplugging the power from each one of those and seeing if it changes anything. Okay, unplugged the soundboard power, and still at 11.28 volts because this 12 volt unregulated is what's used to create the 5 volt regulated. The positive 12 volt regulated creates the 5 volt regulated. So there's a big pool on the 5 volt line, I think. But I'm not an electrical engineer, so I don't understand the right terms, but there's something bringing that down, so be right back. All right, unplug the MPU board, but plug the soundboard back in, and we're at 12.2 or 12.3. So maybe this is completely normal. I'm on a wild goose chase. Let me, I'm gonna actually go measure my Stargate to see what it's like fully powered up. Kind of sucks to see, doesn't it? There we go. So I'm at the back of my Stargate. There's a same identical soundboard. I'm just going to put my test lead on the unregulated positive 12 volts, and we have 10.5 volts. So looks like it's normal. That was a wild goose chase. I didn't like the fact that reading was low like that. So, but obviously that's normal, I guess. And I don't know what, I guess it's not using that voltage for the 5 volts, because it has 5 volts on here somewhere. Yeah, right there. It's got 5 volts to it.
Anyway, all right. Well, I guess that's a wild goose chase. It looks like that's normal with all the 5 volts pulling power from that line. It just brings it down some. So back to the next step. I figured a quick summary for this video because I learned a lot. It took me a lot of time, but all good. So first off, these dip switches up here, everybody on the forum said they're supposed to be off. Not a lot of information on if you put them to on what they do, and I've tried it both ways and I don't notice a difference on this game anyway. But what they do is when you turn them on, they pull a couple lines from this PIA down towards ground, so it won't be completely grounded out because there's resistors and stuff like that, but it's got to be doing something about pulling those lines from, lower or towards ground, because that's exactly what these dip switches do, is they go from, those lines not being connected to ground to all of a sudden those lines being connected to ground somehow. So, and I verified that with a quick continuity test and stuff, except for the top one dip switch, what is it, 2? DS1? I don't know. One of them isn't even connected via jumpers anyway, so it's not going to do anything. All right, so you can look at the schematic and figure that out. The other thing is, yes, the 12 volt unregulated is lower here, but I guess it doesn't matter. I didn't know this, but it appears the soundboard itself is, generating its own 5 volts from that positive 12 volts. So the negative 12 unregulated is probably used for the amplifier or something, or some other sound chip or something. But I guess it's also using the normal logic 5 volt, and I don't know exactly why it needs that, but it's also generating its own 5 volt regulated supply from the 12 volt unregulated. So the fact that it's at 10 doesn't matter. It still can generate 5 volts off of that 10. So I did not know that, and there you go. So now I know. Let's see. Oh yeah, these wires over here, the sound wires that were disconnected. I believe this game only uses 6 of them. So sound number 8 is not connected anyway. And I think it would have had to been connected via a jumper on the board, and it wouldn't do anything anyway because it's not used for this game. So, and I don't know if it's used for any Williams games actually, but maybe other games are using 7 of the sound lines. But this one I think is only using 6. So yes, I put it back in the insulation displacement connector, but the fact that it was out was meaningless. Had no bearing on the game working or not. And I think that's all I wanted to say. So I'm done with this damn soundboard. Screwed with it probably for a couple days and stuff like that. But I learned a lot. So if any of this information helps you guys, that's good. Otherwise, I guess it's just for me. All right. Let's see. What are we going to work on next time? I think next time we're going to work on... I ordered some... I think this is... Where's that CMOS chip? Is this it? Yeah. That chip right there. That 5114. Instead of doing, I think those chips, you can get them from like a Twisted Wrist. Is it Twisted? Yeah, Twisted Wrist Arcade, I think. Or Twisty Wrist Arcade for like $3 or $4 or something. But I went ahead, instead of doing the battery mod on this, I went ahead and ordered the NVRAM version. And I think the next video, we're actually going to also troubleshoot the memory protect switches that are over there as well. So we'll troubleshoot the memory protect. I'll probably socket this anyway so I can put in the NVRAM and avoid using the battery. And I'm trying to think of what else. Maybe we'll also check with a logic probe that chip just to see like the chip enable if it's working and stuff like that. Anyway, so I think I'm going to dive into the CMOS part and trying to fix that error next. And I think that's it. Yeah, and I'm sure I'll find something else to dive into on this thing. So, all right, cheers. Talk to you later.